So besides the partial differential equation, in order to completely specify the characteristics of the partial differential equation that we need to solve, we need to say which are going to be the boundary and the initial or final conditions in the Black-Scholes equation. So there are several things that we need to have in mind. They are important, and we have talked about that earlier as well, but it's important to insist on that. The Black-Scholes equations knows nothing about what kind of option we are evaluating. There is nothing in the partial differential equation that tells you that the option we're evaluating it's a call or a put or something like that. Nor what's the strike or the expiry or the time for maturity. Everything of that will be dealt with the final condition. So to uniquely specify the problem, we must prescribe boundary conditions. The boundary conditions. We have to say which are going to be the boundary conditions in order to see what kind of option we have. So how the solution must behave for all time at certain values of the asset. Usually we're taking s equals 0 and s to infinity. Of course, numerically we can take, you can take s infinity. We have to take a maximum s value you consider which is going to be close to infinity. So you don't need to go farther than that. Besides that, we need to consider which are going to be the initial or the final conditions. Actually, we are usually going to take more. Usually, we're going to consider the final conditions, which are actually it's going to be the payoff at the maturity. So the Black-Scholes equation is a backward equation. So basically means that the signs of the time derivative and the second order derivative in the equation are the same, right in the same side. That's basically, so it basically, as you can see here, is the, so it's different from what we have in the diffusion equation. Therefore, a final condition usually is the payoff, again, the payoff at the maturity has to be imposed. But we'll talk on that later. So how we are doing that change, because usually when dealing with partial differential equation, diffusion equation, you consider what's the initial condition. Here we will have the final condition. So you have to change from this t to another time variable that we are going to call tau. And tau is going to be t, the capital T, which is the maturity time, minus t. And in this new time variable, this tau variable, then what's the final condition for this t is going to be the initial condition for this tau. So this is the time variable change that we are going to make in order to go from the final condition on t to initial condition on tau. So these are the general features that we can say about the boundary conditions on the Black-Scholes equation. It's important to have in mind that boundary and final initial conditions have to be specified in order to say which kind of option do you have. And these boundary conditions or this information doesn't appear in the partial differential equation. Of course, when dealing with different payoffs, we are dealing with different kind of options. For example, that will be the payoff corresponding, or that will be the final or initial condition, depending on what kind of variable, time variable you are considering. So the payoff corresponding to the European call with a strike price E. So basically means you have the option at the maturity to buy the asset with price E. So if the asset value is higher than that, you will take the option, the difference S minus E will be your payoff, while if the value of the asset is lower than that, you will not exercise the option, so the value of the option will be 0. So this is the option, this is the European call option, and the European put option basically is this one, so you have the possibility of selling the asset at the strike price E at the maturity time. So in this case, the behavior will be like that. If the asset is higher than that, then you will not sell that because you prefer to keep that. So the value of the option will be 0. But if the asset is, the price of the asset is lower than E, then you will exercise the value of selling that. Then, and the difference between S and E will be the payoff you will get by selling that asset. And this is a put. But of course, these are just basic, and you are just combined in different ways, and you can see here. And you can build different kind of options like a bull spread option or a bear spread option that's writing in this way. And of course, you can write it mathematically in this way as well. And there are many kind of different pay options, and these are the ones that are fixing the kind of the option you are evaluating. So for example, here we have another 4 ones. So this is a straddle, which is a call and a put with the same strike price. And a strangle, for example, is a call and a put, but in this case with different strike prices, which are going to be given by this form. Here we have a butterfly, which involves the purchase and sale of options with 3 different strike prices. Here a condor is like a butterfly, but in this case we have 4 different strike prices. So here we have, of course, you can build any different payoff you can imagine. And these payoffs are the ones that are fixing the kind of option you are evaluating when you are solving the numerical equation, the numerical partial differential equation that's considering that different payoffs. So again, the kind of option we are evaluating, it's included in the payoff. The payoff is basically the initial or the final condition, depending if you're considering the time t or the time tau, and we'll be using this time tau when solving numerically the partial differential equation, the Black-Scholes equation.